Hey guys, Mr. Backberg here. In this video, we're going to look at solving a system of equations using substitution. So as we're talking about a system of equations, we're talking about a group of equations. And here we've got the equations 2x minus y equals 10 and 3x plus 2y equals 1. And what we're going to be looking for is the x and y ordered pair that satisfies both of these equations at the exact same time. And there are a lot of different methods that you can use to solve a system of equations, but the one we're talking about here specifically is using substitution. So as we're using substitution, what we want to do is look at our equations, and our goal is going to be to try to isolate one of our variables. So we want to look at the two equations that we've got and try to figure out what variable is going to be the easiest to isolate. And as we're looking at these two equations that we've got right now, I think this y in the top equation is going to be the easiest to isolate. So what I would do first is I would subtract this 2x over to the right-hand side. So then that equation would say negative y equals negative 2x plus 10. But then I want to get rid of the negative that's on the y, so I'm going to divide everything by negative 1. So then we get the equation y equals 2x minus 10. And then here's where the substitution is going to come into play. In our second equation, since we solved to get y alone, what we're going to do is replace the y with this 2x minus 10. So then we get the equation 3x plus 2 times, now remember we're getting rid of the y and we're replacing it with what we just said that y was equal to from our other equation. So that's going to be the 2x minus 10, and then this is going to equal 1. Now I'm going to take that 2 that's outside of my parentheses and distribute it in. So we're going to get 3x plus 4x minus 20 equals 1. Combining those x's on the left-hand side, we're going to get 7x minus 20 equals 1. I'm going to add that 20 over to the right-hand side, so we get 7x equals 21. But then we're going to have to divide that 7 over to the right-hand side, so then we're going to get an x value of 3. Now we're not done because we still need to find the associated y value that goes with our x value. Now we can use either one of our equations, but I actually think it's going to be easiest to use this equation that we got earlier when we isolated that y. We're solving to get y, so we might as well use an equation that's already solved for y. So we're going to take this 3 that we just got for our x value, and we're going to plug it in for the x in this equation. So this is going to say y equals 2 times that x value of 3 minus 10. Well, 2 times 3 is 6, and 6 minus 10, we're going to get negative 4 as our y value. So then the answer, we're going to write it as an ordered pair. The answer is going to be 3, negative 4. Now in this example, we're going to look at finding the dimensions of a rectangular garden that has a perimeter of 100 feet in an area of 300 square feet. So we have to remember that perimeter of a rectangle is 2 times the length plus 2 times the width, and the area for a rectangle is length times width. Now we know that our perimeter is 100 feet, so I can plug that in for the p-value on the left-hand side over here. And I know that my area is 300 square feet, so I'm going to get rid of the a, and I'm going to replace that with 300. Now we're going to try to isolate one of our variables, and I'm going to work with the top equation, and let's maybe isolate the length, so the L value in there. So what I'm going to do is subtract this 2w over to the left-hand side. So 100 minus 2w equals 2 times the length, but then I'm going to divide by 2. So then we should get 50 minus w equals the length. So then what I'm going to do is, in my second equation for the length, since that's what we just solved for, I'm going to replace that L with the 50 minus W. So we get 300 equals 50 minus W times W. If we distribute that W in, then we're going to get 300 equals 50W minus W squared. Now because we're dealing with a quadratic equation with the squared in there, we actually want to get this equal to 0. So I'm going to subtract this 50w over to the left-hand side, and I'm going to add this w squared over to the left-hand side. So we should get w squared minus 50w plus 300 equals 0. Now I don't think this is going to factor out nicely, so we're going to use the quadratic formula to help us out. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of the b value is going to be 50 plus or minus the square root of 50 squared minus 4 times 1 times 300 all over 2 times 1 is just 2. Now we're going to get two answers in here because of this plus and minus. So if I do 50 plus this square root and then divide that answer by 2, we're going to get a W value of about 43.03. But if I do the subtraction instead, 50 minus the root and then divide that answer by 2, we're going to get a W value of about 6.97. Now we still need to get our associated lengths with these. So I'm going to use this equation right here where we've got 50 minus W equals L. So if I plug in this value for W and I take 50 minus that W value, then we're going to get the length to be about 6.97. And if I do the same thing with this other W value, then the length ends up being 43.03. So we can see that those are the same numbers. It just kind of depends on which one we're looking at as being the length versus being the width. Now in this system, we've got the equations y equals x cubed minus 6x, and we've got y equals 3x. Now these actually have variables isolated in them. Both of these are solved for y. So what I'm going to do is I'm going to take this 3x right here, because we know that y is equal to 3x, and I'm going to plug that in for y in my other equation. So then we get 3x equals x cubed minus 6x. Now I want to get all of my x's on the same side, so I'm going to subtract this 3x over to the right-hand side. So we're going to get 0 equals x cubed minus 9x. Now there is actually some factoring that we can do in here. We can take out a GCF of x, so then we're going to get x squared minus 9, but then we're going to be able to factor this out a little bit more because this is a difference of squares. So this is going to factor into x plus 3, and x minus 3, and all of this is equal to 0. So because we've got this equation that's equal to 0, then what we can do is with each one of these factors, set each one equal to 0. So we're going to get x equals 0, we're going to get x plus 3 equals 0, and we're going to get x minus 3 equals 0. So this top one is already solved, so we've got that x value. So x equals 0 is one of our x values. In this second one, we're going to have to subtract that 3 over to the right-hand side, so we would get x equals negative 3. And in my last one, I would have to add that 3 over to the right-hand side, so I would get x equals positive 3. But we still need to find our y values that go with these x values. So I'm going to use this bottom equation right here, because I think that's going to be the easiest to work with. So we've got 3 times x, and we just have to plug in our x values. So if I plug in 0, then we're going to get a y value of 0. So that's the ordered pair, 0, 0. If I plug in negative 3, we're going to get a y value of negative 9. So that's negative 3, negative 9. And if I plug in positive 3, we're going to get a y value of positive 9. So that's the ordered pair, 3, 9. That's going to be it for this video. Thanks for watching.